Action 1, inspiring action. Action 1, inspiring action.
Look up because you never know what you will see. Hi, my name is Shen Ge, and I'm the host of SG2 on Space, the only weekly space show here in Houston, with Action One Media Group support every Thursday night. So, my goal here is to educate the public in terms of space science, space flight, physics, astronomy, etc. All that cool jazz, and occasionally about aliens as well. So STEAM education, science, technology, engineering, arts, since that's part of the creative aspect, and mathematics is very important to me. And I feel like Action One Media's goal is aligned with mine. So together, we hope to encourage the knowledge and especially the passion and interest in outer space in our Houston community. Tune in to SG2 on Space on Thursdays at 8 p.m. U.S. Central Time. Look up because you never know what you will see. Okay, everybody, this is SG2 episode number 35. You're listening to SG2 on Space every Thursday night, broadcasting live in our lovely studio here at Action One Media here in Houston, Texas. SG2 on Space, it's the only weekly space show in Houston. And you can view us either live or, if you miss it, you can watch previous episodes on YouTube. You can search for SG2 on Space. You can also watch it on my Facebook page, which I hope you will follow at facebook.com/The Shen Show, TheShenShow. That's facebook.com, of course, in front of that. And also can watch it on the website of Action One Media at weareA1.com. All right. So, and of course, I'm also going to state here that I'm actually revamping my Patreon page. So when that happens, I'll let everybody know. And of course, I'll be happy to have your support for the show because it does take me time and effort and some money to keep this show going. So, in any case, let's get started. So today, I want to talk about. So we've been talking about the moon for quite a lot in the previous couple of episodes. So figured that talking about something beyond that, which for me is life beyond, that would be interesting. So that's the theme today, the life beyond, okay? So but before we get started, I would like to have a couple of interesting announcements. These aren't big policy making announcements like I have been doing. So let's just go. Okay, so International Astronomical Union. Apparently, there's a competition that they put out where you can name your own star and exoplanet, which is kind of cool. So this is in honor of the IAU, the International Astronomical Union's 100th year anniversary. So they organized the 100 IAU Name Exoworlds event. So in this competition, every country in the world could have the honor of naming an exoplanet and its host star. So the idea behind this contest is to, the typical build an understanding of our place in the universe, foster fraternity and citizenship, So they've actually done this before, despite some controversy. So, for instance, they did this in 2015, and 14 host stars and 31 exoplanets received names. Now, it's up to each country to organize their own effort to name a star/planet combo. The candidate systems will be chosen for each country by the IAU, right? So the IAU says, okay, look at this exoplanet and this star, all right? And here's your name for it, okay? So, that's cool. The name system now will be visible from the capital city of whatever country it is. So I suppose that means for smaller countries, you kind of have a more limited pool from what I see. But hey, that's kind of cool. You can, if you want to get into it, I suppose you could go to their, just look up 100 IAU Name Exoworlds event, and look into how you can probably propose a name for your particular country, um, to then propose to the IAU, right? So, okay, another cool thing about besides naming star, I thought this was interesting. There's so I really like scientific visualizations, science visualizations. In fact, I wish I put something there. Oh well. So science visualizations are essentially, plotting out data and so forth of science, right? So there's this woman named Eleanor Lutz, Lutz. She's a PhD student in biology at University of Washington, and she has a pretty cool website called Tabletop Whale. So done a bunch of various stuff like visual compendium of glowing creatures, topographic map of Mercury or Mars or whatever. So the newest project, though, is gaining a lot of attention. She's working on Atlas of Space. So it's basically a collection of 10 visualizations, including planets, moons, and outer space. So this has anime map of the seasons on Earth, a map of Martian geology, and a map of everything in the solar system bigger than 10 kilometers. So, and there's actually one that has asteroids, right? Like there's 10,000 asteroids that are over 10 kilometers in diameter, about 8,000 objects of various sizes, and it's all visualized and it looks beautiful. So you can check that out at tabletopwhale.com. Tabletop tabletopwhale.com. Okay, so those are two of the interesting things. I also like to add that I may be this I need to get more details on this. So there's a space app hackathon that happens every year that's organized by NASA, right? So sometime in October, I believe. And I noticed there isn't one in Houston, which for at least I haven't heard of anything organized for this year, which surprised me. And the last time this was done was 2 years ago in 2017. There wasn't one last year. So essentially what this is, as all hackathons are, is, you have a bunch of challenges, and then you get together and you basically work on it for like a day or 2 days, right? And you work in teams with other people, and you come up with ideas, and you develop something by the end of that day or 2 days. And then you submit it. You can submit it through the online, right? So you could do this individually, but that kind of defeats the community spirit of a hackathon, right? It's when people actually come together to solve problems. So my idea here is, I figured if nobody else is doing it, who knows? I might organize it. But I need to get more details. So as I get that, I will actually let all of you guys know what the status is, and hopefully get some attention and get that going. So, all right, let's jump into a little bit about something else. So, as noted, what I like to talk about for today's theme is life, particularly life in other worlds. So, Enceladus. Does anybody know what is that? Is that a planet? That's not a planet. All right. Is that a moon? Is that an asteroid? Is that a star? 5 seconds. All right. So you guys are thinking about it. All right. It's a moon. All right. So it's one of Saturn's moons, right? So what is special about this moon is that it has a subsurface ocean. All right. And essentially, scientists say wherever there's water, there is life, or at least the potential for life, right? So Enceladus is actually a really small moon, it's only about 310 miles, in other words, 500 kilometers across. So it is smaller than our moon, okay? So however, it's subsurface ocean, so it's icy covered, right? So underneath, it's of great interest since it could have a similar pH, salinity, which is basically the amount of salt concentration, and temperature to Earth oceans. All right. So also, how did we observe this? Well, we actually observed these details in these details. We actually know a lot of this through the Cassini spacecraft. So the Cassini spacecraft, remember, was a mission to go, not unfortunately, it retired last year, right? The Cassini spacecraft's mission was primarily to go to Saturn, right? But along the way, it noticed that there were gigantic water and ice spewing out from the surface of this moon, right? So scientists had Cassini do a detour to get closer to the moon in order to get more details, and that's how we learned a lot of these things, right? So these plumes actually erupt at like 800 miles an hour, which is ridiculous. So now these plumes, we don't have a means of like drilling under the ice. You know, you actually have to go there and look under it. So, but these plumes provide an opportunity for us to at least get some idea of what's underneath, right? So, what this particular team did is that they looked at the data from the Cassini mission with some computer simulations and counted for various factors to get a clear idea of the interior, right? So let's show a little video, but before doing that, let's take a little quick break. When we come back, I'm going to show the video and talk a little bit more about this. So let's take a break.
Some of the other things you got going on.
Absolutely. So thank you for having me. I feel like I'm in the presence of like celebrity. Y'all real fans to me.
It's just the shades, man. It's the shades.
So I think like 2000.
Put your money where your community is. Get in the action. Action 1. Independent thinkers working together. Inspiring action in media. Get in the action. Inspire today. Join us by being a sponsor at weareA1.com.
Growing up as a black kid in New Jersey, all I ever wanted to do was be a pro athlete. All of my role models were black athletes. And every time I would stare out the window, look at the sky, and wonder what I'd be in the future, it always had to do with me catching some crazy football and scoring a touchdown. When it came to the point that I was told that I would not be able to play on an organized sports team for the rest of my life, it was something that I really didn't even know how to stomach in the moment. And I remember walking out of my cardiologist's office and just sitting in the hallway and breaking down for a few minutes just because it was something that I just couldn't plan for and couldn't account for. And I realized that in that moment, my entire life was going to be changed. And all of those dreams and hopes and aspirations that I had were going to go out of the window.
All right, so we are back. You are listening to SG2 on Space. This is episode number 35. So, SG2 on Space, the only weekly space show here in Houston, Texas. And of course, I presume you're watching this on YouTube. You probably looked up SG2 on Space. Or on Facebook, facebook.com/The Shen Show. Follow me, by the way, if you haven't already. And of course, www.weareA1.com, which is the media studio where I am right now. So, with that, before we went on break, I was telling you guys that this week's theme is on life, particularly life beyond Earth. So before we went on break, I was telling you about Enceladus, which is give you guys a 5-second guess on whether it's a planet, a moon, asteroid, comet, whatever, star. And some of you must have gotten it. It's Saturn's moon, Enceladus, right? Pretty tiny, but has a potential for harboring life, right? So let's watch a little short clip, which will provide that a little more detail and actually have some graphics, which I can't demonstrate with my waving arms. So let's do that. All right, so you guys have seen a little bit. So what exactly is happening here is that the University of Washington, right? Researchers there are looking into building a model. And in fact, they have built a model, all right? And what they found is that there's significant actual differences between the plume that basically came out of the surface and the Enceladus' ocean chemistry that's beneath the ice, right? So the previous interpretations did not take into account some of the other factors, and the previous simulations underestimated the presence of hydrogen, methane, carbon dioxide in the ocean. So there could also with a simulation be high concentrations of ammonium as well, which is a potential fuel for life. Okay, so this is actually quite promising. This is a good sign. Now the researchers can use this gas concentration to determine an upper limit that for certain types of possible life that could actually exist in this really icy ocean of Enceladus, right? So who knows? We can see. Now, let's put this on a big screen so you guys can watch it in a little more detail. We shall do that.
In 2005, NASA's billion-dollar probe Cassini is on a flyby past Saturn when it captures images of something unusual on the icy moon Enceladus.
There are what seem to be bright lights coming from Enceladus' south pole, shining out into space.
Enormous plumes of a mysterious vapor are jetting from the frozen moon's south pole. They look so like the geothermal eruptions found on Earth that scientists immediately call them geysers.
There are geysers shooting out from the side of this tiny little moon.
The plumes above Enceladus are more than 8,000 times larger than any geyser found on our planet.
So here we have these geysers.
By repurposing the instruments that were on the spacecraft, we've really adapted the spacecraft to be able to do something that we never really intended it to do.
They're going to buzz the surface of Enceladus, fly right through the plumes, and see what they're made out of.
NASA's mantra in the quest for life anywhere in the universe is follow the water. Could these mysterious plumes be made of water? And could this water harbor alien biology?
Where there's liquid water, that's one of the key steps to finding potential life.
The scientists are looking for 3 key conditions that led to life on Earth. Liquid water, a high salt content, and evidence of a hot active core deep beneath.
All right, I think that was a rather dramatic video. A lot of these have really epic music in the background. So, future explorers out there listening to this show, make sure to turn on your epic music on your spacecraft when you head over there, right? I'm kidding. All right. Point is, so we'll see what happens. You can do all the simulations you want, but eventually you will need to send a probe over there to confirm your suspicions. So, it's interesting unless some giant alien come out of the surface or something, or some life come out of it and we send another spacecraft over there. We can't really confirm any of this, but hey, it's good to know. At least we know how should I put it? These simulations enable us to basically justify a greater reason to go over there, right? If we say, hey, there's a really good chance that we have this watery environment that's similar to Earth, maybe we should send a mission over there. That would be a good justification. All right, so another thing, I don't know who knows about brown dwarfs. This may not be so relevant exactly for life, but I've always been interested in these little objects. So, brown dwarfs, all right, so there's a newly detected brown dwarf designated EPIC 212036875b. Clearly is not renowned enough to have a common name. It's 50 times more massive than Jupiter, so it has 50 times more stuff, right? But it is actually smaller than Jupiter, all right? So what are brown dwarfs? They are intermediary objects between planets and stars. So unlike a star, they haven't undergone fusion, so they're not shining bright. But unlike a planet, they have, generated enough internal thermal energy where, and they're huge, that they're not really considered a planet either. So they occupy the mass range between 13 and 80 Jupiter masses. So notably, out of the 2,000 brown dwarfs detected so far, only about 400 of them were found to be circling around stars. So the other 1,600 or so were just on their own. So now, observations. This is pretty cool since brown dwarfs typically with masses between 35 and 55 Jupiter masses are that orbit, say, a host star at less than 3 AU, astronomical units. So 1 AU is the distance from Earth to the sun, okay? So at less than 3 times the distance from Earth to the sun. They're extremely rare to find. So, and these are called brown dwarf deserts, right? So it's pretty cool that we found one of these. Okay. So anyways, what exactly does this mean? Well, we found a fairly rare object. Now, whether the star system has life, that's a different story, right? We're not exactly quite sure about that. I will tell you this, though. There is something else that is really interesting. This week, we've also detected a Earth-like exoplanet that's around a red dwarf that was only discovered in 2003, even though it's only 12.5 light years away. So let me talk about that a little bit. So the star, the Teegarden star, Teegarden star, is only 12.5 light years away. It's a red dwarf. So red dwarfs are actual stars. In fact, they're the most common type of stars in the universe. They're the dimmest kind of stars. Okay, so surface temperature is 2,700 degrees Celsius, mass about 1/10 the size of the sun. This particular one, well, red dwarfs in general are pretty faint. But this one, since it was so faint, we didn't discover it until the year 2003. Okay, so lately using the Carmenes, CARMENES high resolution spectrograph at the Calar Alto Observatory in Almeria, 2 new planets in Earth, and 2 new planets that's similar to Earth in the habitable zone were discovered, okay? Which is really interesting. So, man, that's not very far away. That's only 12.5 light years away. Can you imagine, like 2 Earth-like planets? All right. So both of these planets are rocky planets similar to the ones in our inner solar system, right? Mercury, Venus, Earth, Mars, all right? They're just a little bit bigger than Earth, and it's completely possible that water could exist as a liquid. So this is really cool. Now, these scientists took a while to do this, right? It's not like they just used this spectrograph and they got the data. It took them 3 years. So what they used was, and it wasn't just the Carmenes high resolution spectrograph. They've been carrying out instruments such as the Muscat 2 on the Carlos Sanchez telescope at the Tigre Observatory in Tenerife, which is in the Canary Islands, by the way. Guys, you should check it out. It's beautiful up there. And with a network of telescopes of the Las Cumbres Observatory and some others, right? So how do they detect it? They detect it by transits. So transits, I think I talked about this before. So imagine you have a light source. Let me see if I can pull out this phone. Light source, flashlight. Ooh, yes. See, here's a light source, right? So phone, light source. Now imagine you as observer, when this cup crosses in front of this light, guess what? This light source dims, right? So you see a dip in the light curve, and then goes around, and then dips again, and then goes around, dips again. Okay, you need to observe a lot of it, right? Because there's noise in your measurements and so on and so forth, right? by doing that, you have to be lucky, right? Since you have to be right there. Like, what if this was like orbiting like this? Then you would never see a transit, right? So using this method, you're only limited to watching certain ones. But when you can detect it, which is it's pretty awesome, okay? I mean, it's a very simple concept, you know, shadow, block light, reduce light, okay? You can't ever observe these planets directly. It's not like you can see a cup. I mean, just imagine this being super bright and this being super dim and really tiny. So essentially, you have to observe. You have to be very careful and observe how little the light dims and see that it's periodic, right? Every orbit. And then you can detect, you can figure out the size of the planet, obviously its orbit, and from that, you can know quite a lot. So in this case, you'd be like, hey, this is about the size of Earth, okay? And using some other methods, you can detect the elements on the planet, right? So then you can say, okay, this is a rocky planet. It's kind of similar to Earth. Its orbit is like this, so it's in the habitable zone, so it should be not too cold, not too hot. So possibly have life. So anyways, that's a short description of the transit method. All right, which is really interesting. So guys, you can read that article in the latest issue of Astronomy and Astrophysics. So just look up, I guess the main author is Victor Sanchez Bejar, Bejar, and Victor Sanchez. I'm not going to spell that. So just look it up, Astronomy and Astrophysics. So cool stuff, right? All right, another thing, before we jump into some of the exciting space projects that's going on, actually, might as well talk about it now. So one of them is, speaking of detecting life on other worlds, which these two exoplanets might be, SETI. SETI stands for what? Okay, well, Search for Extraterrestrial Intelligence, SETI. They recently released a massive data dump online for the public. All right. So let me give a brief overview, right? So SETI for years has been looking, and they're still doing this, scanning the sky for radio frequencies, right, which could be signs of intelligent life. In other words, techno-signatures, that's what we call them, evidence of technology, right, such as transmitters or propulsion devices built by civilizations beyond the Earth. All right. So, so they built on the results presented by a team in 2017 that reported on the analysis of 692 stars. All right. So they, by they, I mean the Breakthrough Listen project. All right. So essentially, Berkeley's, let me clarify. There is something known as the Breakthrough Initiative. So the Breakthrough Initiative, this is the background. The Breakthrough Initiative are a set of scientific and technical programs really far out there, founded by Yuri Milner, who's, I believe, a Russian billionaire. Correct me if I'm wrong. And essentially, he's funding these massive projects. One of them, which is this Breakthrough Listen project. Another one is called Breakthrough Starshot, which is sending small satellites to Alpha Centauri within 20 years or something like that, which is also kind of crazy. All right. So this Breakthrough Listen project is to detect signs of, techno-signatures from extraterrestrial civilizations, right? So so what exactly is this? They teamed up with Berkeley, all right? So they have a science team there at University of California, Berkeley, which is essentially studying this, right? So this team analyzed 692 stars, and they observed some more. Breakthrough Listen team now took that, observed some more, and just analyzed data for 1,327 stars, all right? And they got more stars to look at, and they've been doing this for the last 3 years. Okay. Now, these data sets, which is apparently, I don't know how you even say this, 1 petabit? I don't know. It's like 1 petabyte, which is huge. All right. I mean, that's like, 1,000 terabytes or something like that. Anyway, all this is actually publicly available. So you, whether you're a researcher or just an everyday person, can go through the data and do whatever your own algorithms or whatnot and analyze it, and maybe you detect some aliens. Who knows? Who knows what you would discover, right? So you can go online and look at Breakthrough Listen Open Data Archive. So Breakthrough Listen Open Data Archive, right? And there's also what is it? There's also data, not just the stars, right? Not just that data. There's also not just stars and radio, whatever frequencies detected. There's also scans of the interstellar asteroid, supposedly asteroid. I still think it's possibly an alien spacecraft. Interstellar asteroid Oumuamua, and optical data from APF. Okay, so you can feel free to take a look. And if you don't know how to look at the data, they have 2 research papers out which explains what they did and what you can do with the data. So anyway, so just look at just do a search on Breakthrough Listen, and I'm sure you will have a lot of fun. So with that, let's go on, right? Let's talk about the massive projects that are under works. Aside from that, so Breakthrough Listen is cool, but what about new kinds of telescopes to detect exoplanets? Well, it turns out there's one that I find really interesting, which is called Starshade. All right. So I already talked about the transit method, where, all right, so here we go. All right, I don't have to do this again, but essentially like that, right? But remember, the transit method only works if we're lucky enough to be on the same viewplane, right? To block enough light. Otherwise, we would notice no distinguishable difference in the light. So star shade is essentially a gigantic shade, just like how say the sun's shining and a bird is passing by, and you can barely see the bird, so you cover, you hold your hand out, you block out the sun, right, so you can see the bird or whatever else you're looking at. So essentially you're blocking out the star to see the dimmer object, right? So so what this is imagine a gigantic sunflower shade that unfurls and blocks out most of the light of a sun. And then you have a telescope far away. I mean, that looks through the hole in the middle, so to say. So you block out most of the light from whatever sun you're looking at, and then you look at it, then you can see everything else. It's a massive project. Sounds, pretty straightforward, but you need to have extreme precision. So, now, the way we have been doing it, which has been able, has detected over 4,000 exoplanets so far, there is a certain limit to the size we can do this, right? Because if you imagine, say, a planet smaller than the size of the Earth, or even the size of the Earth, it's really hard to detect because we're so small. We don't really have that much effect on dimming the light of another star, right? So the only reliable way to actually detect smaller rocky planets is through direct imaging, which is what this allows, what star shade allows. All right. So I could explain all this, but really having a wonderful video showing that would be fabulous. But let me explain this a little bit more, then we can take a break, and then we come back and see the little video. All right? So, this telescope is going to be able to spot any planets, any of them, that orbit a star. All right? However, in order for this to work, it has to have ridiculous precision. So, the sunflower unfurled shade and this telescope observation, right? They need to be 40,000 kilometers or 24,850 miles apart. All right, and they have to maintain that distance apart, and they can't deviate by more than 1 meter. Like, that's pretty ridiculous. So they're like almost 25,000 miles apart, and they can't move, they can't change their position by more than 3 feet. All right, they just have to maintain it. Otherwise, you're off. All right, otherwise you can't see any exoplanets. So can you imagine that? Well, that's kind of hard to imagine, all right? But let me give you an example. So if the star shade was shaded down to the size of a drink coaster, say, like a little coaster, the telescope will be the size of a pencil eraser, and it'll be separated by about 60 miles. So essentially, this is like a coaster. I'm going to drink. Essentially, imagine this is a coaster size. All right, that's the star shade, and this is the telescope. Say, imagine this here, just the top of this. These two are going to be separated by 60 miles, 100 kilometers, and they can't move by more than 2 millimeters. That's how precise you have to have it. All right. Hopefully, this will soon get off the ground. I think it's still in the design phase, but hey, I'm looking forward to that. All right. With that, let's take a short little break. When we come back, like I said, we'll watch a short little video, and then we'll talk about something else.
Put your money where your community is. Get in the action at weareA1.com.
Man, you still here? Go on and subscribe.
Get into action. Yo, we back at it again, baby.
What?
Get into action.
3.
Get into action.
Tell me what is the deal, tell me what is the deal.
So I challenge you today to start strong.
Get in the action.
Tell me what is the deal. Cause I'm calling for you.
Get in the action.
Can you feel that? See, I'm calling for you. Can you feel that? See, I'm calling for you. Can you feel that? See, I'm calling for you. Say how you really feel.
All right, so we are back. You're listening to SG2 on Space, episode number 35, The Life Beyond, talking about planets, talking about possible life, beyond our solar system or within our solar system. So SG2 episode number 35, you're watching us on YouTube, SG2 on Space, Facebook, I presume, facebook.com/The Shen Show. Without further ado, before we went off air for a bit on break, we're talking about Starshade, which is a new type of telescope to directly image a planet by blocking out completely, like a giant sunflower cover, the star that you're looking at, so then you can observe the planets without the star's light interfering. So let's see what we have here. Note that this is currently being studied at NASA's Jet Propulsion Laboratory in conjunction with NASA's Exoplanet Exploration Program, XEP. And so they're working to actually create the starshade. So let us see.
Here's the problem. The planets are orbiting extremely bright stars, sometimes than the reflection off the planet. But if you can block just the light from the star, all of a sudden you can study the planet in more detail. Let's go figure out how to block a star's light on this episode of Crazy Engineering. All right, we're here with Nick Siegler in this very fun-looking lab. Nick, can you tell us a little bit about where we are?
Mike, we're in JPL's Starshade lab.
What exactly is a starshade used for?
Mike, there are two techniques that NASA is advancing to look for life on exoplanets. The starshade basically is a large shade that is flown outside of a telescope with the intention of blocking the light of the star. So then we can see the planet's light skirt the shade and captured by the telescope.
Okay, so this is much like I'm looking up at the sun and I want to see a bird or an airplane. I put my hand up to block the sun's light, but we have to do it on a much larger scale for a star.
The starshade itself is tens of meters in diameter. That's the size of a baseball diamond.
Just about how far away from the telescope would it have to fly?
It's tens of thousands of miles. You can fit like 4 Earths between the telescope and the shade. It's got its own propulsion system. It's literally its own spacecraft.
how do we get it up into space?
That's the engineering challenge, is how do we get something that has to deploy to tens of meters in diameter that could sit on top of a rocket? So now our engineers have come up with a technique based on the ancient practices of origami.
All right, so
Sounds
ain't that
difficult.
interesting that they're
How do you
working
know
on
that's
stuff like that? Well, guess what? You know, NASA can't have all the fun. Let's go. Remember, I talked about Planetary Society, formed by Carl Sagan. Carl Sagan, he's one of my heroes. Definitely influenced me to a degree. But anyways, he formed a nonprofit called the Planetary Society, which is outreach, education, as well as technology projects, demonstrating, you know, potential ways to that could change everything. One, for instance, is light cell. So, what is a light cell? Light cell is essentially a very large, thin film made of, in this case, mylar. So it's so thin, it's less than a human hair's width, okay? So imagine that. And it's actually kind of funny. It's a light cell because it's not heavy, it's light, but it's also called a light cell because the way it moves is by the photons hitting it, okay? By light particles, basically. Light particles are called photons. Photons carry momentum. Remember, momentum, you know, pushes, right? Yes, light does light has no mass, but it does have energy, and hence when it hits something, you can actually push it. So not very much, but these light cells present a alternative form of propulsion which requires no propellant, right? Since all you need is light coming from the sun. This was actually first theorized in 1600s when Johannes Kepler, who developed Kepler's 3 laws, one of the foremost astronomers back in the day, and everybody will have to learn his laws if you ever take astrodynamics, but okay, that's besides the point. So he talked about sailing amongst the stars. Now, he probably didn't know that photons, you know, actually push objects, but hey, he was all poetic and said it could be adapted to the heavenly breezes. Now, it turns out that this is actually real. So, Light Sail 1 failed back in 2015. It experienced problems, and it couldn't really, you know, deploy the sail. Light Sail 2, which is going to launch in 5 days, well, depending on when you're listening to this, I should say the date, June 25th, 2019, SpaceX Falcon Heavy. It's going to lift off from Florida, and it's going to carry the satellite, right? And yeah, it's in a little CubeSat. You know, it's gonna unfurl. It's gonna be beautiful, unless it fails again. Hopefully not. This one has an area of 32 square meters, and it's a test demo, right? Ideally, it would just unfurl and let the sun hit it, and it should be able to move to a higher orbit. So let's watch a little short clip here because that actually shows a little bit about how the stuff is arranged. It's a 3D CAD model. So now, why is this important? Why are we getting that? Well, like I said, it requires no fuel. So it could really facilitate deep space exploration, right? So even though it starts off much slower than a spacecraft that uses, say, traditional chemicals, it can continue to accelerate permanently through space. In fact, the Breakthrough Starshot program, which I said is sending satellites to Alpha Centauri in less than 20 years, the only technology that we know that we can develop so far that can do this is through a light sail. All right, like no chemical propulsion could do it, or electric. All right. So the other application of immediate application is maintaining a probe at a stationary spot in space. If you want to maintain a stationary point in space, you need to have corrections, right? Attitude corrections. So then you need propellant, and then if you want it there for, like, say, 10 years, you're going to need an enormous amount of propellant, which is very infeasible with that. But it's perfectly feasible for these fine adjustments if you have, say, a solar cell. All right, let's take a look. All right, so that was great, right? Next time we'll put it on full screen. But hey, you can go to Planetary Society and look up Light Sail 2. And of course, don't miss the launch of it. And guys, this is really cool because assuming successful, guys and gals, you could actually see this because it reflects sunlight, right? Mylar is a very highly reflective material. In fact, when you design these things, you want it to be really thin, so reduce the mass, large area, and highly reflective. All right. Why? Because you get double the momentum if you bounce a photon, right? Versus absorbing it. Okay. It's like, all right. So it should be really bright, and you should be able to see it from Earth when it passes over. Assuming it's within your line of sight. So, all right. I'm going to talk about one more thing. Nah. Well, I will talk about it, and then I want to talk about something really interesting that happened today with UFOs stuff. So, just very briefly, there's NASA's developing inflatable heat shields to deliver payloads, basically deliver stuff on other planet surfaces. So eventually, when we explore these other worlds, okay, to find life, let's just say, and bring life of our own, which will be us. All right. We need to figure out a way how to do that, right? So one way to do this is using some kind of inflatable decelerator. So it goes through the atmosphere, and think of it like a balloon thing that basically, and then decelerates when it goes down, right? So versus using traditional really heavy retro rocket propulsion, which you probably see like firing rockets and then landing, right? And really rigid heat shields, which adds a lot of mass, and then you're going to have this really fine descent control. All right, so interesting technique. You guys could read up more about it. Just look up hypersonic inflatable aerodynamic decelerator. Originally, I was going to play a little video, but for the sake of time, let us skip over that. However, you could definitely watch it. Like I said, just look up. Oh, this in particular is called Low Earth Orbit Flight Test of an Inflatable Decelerator. And by 2022, NASA's hoping to send this prototype to low Earth orbit, where it will be tested and eventually tested on, say, Mars. Okay, it has to be a world that has an atmosphere. It wouldn't work on the moon, since you need an atmosphere to decelerate, drag. All right. So what is this UFO thing, right? Well, guess what? Today I just received news of this, or rather, I just learned about it. A group of U.S. senators, including the vice chair of the Senate Intelligence Committee, received a classified briefing about a series of reported encounters by the U.S. Navy with unidentified aircraft. Now, remember that happened like a year ago when that video came out, the really famous one, that showed that Pentagon was spending money on this secret UFO group project? All right, so Rachel Cohen, the spokesman for Democratic Virginia Senator Mark Warner, said, if pilots at Oceana or elsewhere reporting flight hazards that interfere with training or put them at risk, then Senator Warner wants answers. It doesn't matter if it's weather balloons, little green men, or something else entirely. We can't ask our pilots to put their lives at risk unnecessarily. So, yeah. So follow-up discussions with other interested are... okay, I think they probably already talked about it. So they started the conversation on Wednesday. Then they have more conversation on Thursday, June 20th. And this is completely classified. So, sorry. We don't know what they're going to say exactly. President Donald Trump, he was also briefed on reports of these Navy pilots spotting unidentified flying objects. But Trump being... okay, let's not turn political here. Trump basically said he doesn't believe it. Not particularly. Which, okay. Well, anyways. But pilots, of course, that encounter this has said that there are multiple encounters with UFOs. Basically showed these things flew like super fast and stopped super fast with no visible engines and no infrared exhaust plumes. All right. And as I was telling you last time, since April 2019, the Navy has introduced guidelines for pilots to report these unexplainable events to the military, so we can keep track of them, all right? So we're now more open about it instead of openly dismissing it, right? Probably, I think some part of it might be the increasing geopolitical tensions with, other countries, which yeah, why not, right? So who knows? It might be, some people might think it's a Russian or Chinese or whatever other aircraft. So the Navy has said there has been a number of reports of unauthorized and/or unidentified aircraft entering various military-controlled ranges and designated airspace in recent years. The Navy said these kinds of incursions pose both a security risk and safety hazard. For safety and security concerns, the Navy and the U.S. Air Force takes these reports very seriously and investigates each and every report. Whoa, so the senators are briefed now. So I guess Congress is now taking it seriously versus just dismissing it. My perspective, as always, I already think that there's some people in the government that already knows everything about it. Now, hey, like, what, you know, why are they keeping it secret? In other words, I don't know. I mean, I figure that this thing is, if, say, it's publicly known that there are extraterrestrial intelligences here on Earth and they're observing us or making deals with the government and none of us know about it, well, that would create an outrage. And actually, you know, that would have huge repercussions societally. I mean, we've always considered ourselves unique in a certain way, right? We're supposedly, as far as we know, the only intelligent species in, you know, that we know of. So to discover that we're not, and we're like far inferior technologically and probably sociologically and whatever, that's going to have a huge blow on our sense of self-worth, and to extent, for some people at least. And considering the various religions in the world, which seems to place humans above, you know, animals and plants, I don't know how that would fit in. So I think there's a good reason for, you know, keeping this all to a degree secret. I don't think the military, this is of course me talking, should be highly concerned about, you know, UFOs, assuming they're extraterrestrial intelligences doing anything, because they could have done that years ago, like during World War II, say, when we barely had any technology to this level. But hey, okay, in any case, let me sum it all up, right? I mean, we took about, you know, going to Enceladus, going beyond the stars to exoplanets, and then taking it back to Earth, where apparently senators are briefed on UFOs. So who knows? We may not be needing to look far out. But I will say this, no matter what, doesn't matter if you have a telescope or not, or you're a researcher, you got your eyes, right? So if you have eyes and you're not blind, then wherever you go, whatever you're doing, assuming you're not driving a car, because I don't want you to crash, look up, because you never know what you will see. This has been SG2 on Space, episode number 35. And with that, I bet, you know, guys, have a good night. And like I said, be sure to follow me, facebook.com/theshinshow. And of course, look for Action One Media Group as well. Follow them on Facebook and go to their website, www.weareA1.com. Take care. Look up, for you never know what you will see.
Action One, inspiring action.
Look up, because you never know what you will see. Hi, my name is Shin Ge, and I'm the host of SG2 on Space, the only weekly space show here in Houston, with Action One Media Group's support every Thursday night. So,
Peace, it's Brother Atum Ra, and you tuned in to Action One Network.